your 12.3 homework. Did everyone do it? So Chen, do you do? Good. Rain, do you do 12.3? Yes, great. Okay, any issues regarding question 4? Question 8? Question 10? 8. 8 have what? 8 had what? 2. And then amend your question 10. Or question 10. Okay. What about question 11? Okay. Alright, let's look at question 8, part 2. We want to find the x-coordinate of the point when dy over dx equals to 0. So just do a quick check that your dy over dx is equals to this. Which simplifies to this. Then for part 2, we want to find the value of x when dy over dx equals to 0. So we let this to be equals to 0. Okay, so in order to solve this is that we will multiply throughout the entire equation by 2 square root x. That means for this first term, you have to multiply by 2 square root x. And in the second term, 2 square root x will disappear. Okay, in the denominator, just disappear, cancel already. And on the right side, 0 times any number remains at 0. Okay, so square root x and square root x will become an x, so you get 8x over here. Okay, then we can factorize out the x minus 3 cubed, such that we have 8x plus x minus 3. Okay, then we see that x minus 3 cubed will be equals to 0, or 9x minus 3 is equals to 0. So x minus 3 equals to 0, x equals to 3, 9x equals to 3, x equals to 1 third. Okay, so those will be the x-coordinate of the point. Right? Okay, there was no need for you to go and expand. I hope nobody expanded this, because surely you do not have the capacity to actually solve a degree 4 polynomial. Okay? Any questions for 8 part 2? Alright, let's look at question 10. May I know what is the challenge in question 10? Amanda, what was the challenge? Do you understand the question? The question says the equation of a curve is given to be something. We want to find the gradient where this curve meets another line. So the challenge was, don't know how to start?
After I found the dy over dx.
You find dy over dx of what? Which equation? The first one or the second one? First one. Okay, you find already then. You need to substitute a point, right? You need to substitute x in order to get the gradient, right? So, what is the x that you should, how do you find the x value to substitute in?
Wait,
Sorry?
simultaneously.
Yeah, you solve simultaneously. Because the question says the equation of a curve is given to be the first one. We want to find the gradient of the curve at which the points where it meets the line. So the curve meeting the line, okay, so to illustrate the thing, we are looking at a case of maybe something like that. Because it says it meets, it doesn't say how it meets, okay, just an intersection. So this can be y equals to x, and this could be the curve. So we just want to know what is the gradient at this particular point. So we solve simultaneously. Okay, so could you do that? Okay, and then you will get x equals to square root 8 or x equals to negative square root 8. Okay, you managed to do that? Then you differentiate, right? So something I want to point out, right, in your working, so I skip through the simultaneous. When you differentiate, okay, because you notice that there are two y's over here, so in your presentation, it will be best if you write down what exactly is it that you're trying to differentiate in the line before you do your dy over dx. Because if you write two lines like that of y, okay, and then your next line dy over dx, it is a bit ambiguous to know whether your dy over dx is for this one or dy over dx is for the first one. Okay, so when you do your dy over dx, right, in your presentation, write the necessary equation first, then you put your dy over dx. Okay, so in this case, I'll skip through the process of doing your product rule. Upon simplification, you will get this. Okay. Oh, sorry, I forgot. There's still one more x equals to 0. There are 3 coordinate points, right? Okay. Are you able to get the 3? Anybody not able to get 3? Okay. So the reason is because you simply divided away the x. Okay. So just to show that, do your substitution, right? You cannot cancel like that. Why cannot cancel? Why is it that we cannot cancel? I've addressed this last year. Why? So who got managed to get x equals to 0? Johnny managed to get x equals to 0, right? So why do you not cancel? Or how do you get x equals to 0? So why do you do that? It seems correct, what? You can cancel away the x. So why can't we do that? Answer? Because x can be 0. Okay? X is a variable where you do not know what is the answer. Okay? And if x is equals to 0, we cannot divide by 0. Alright? So therefore, we cannot divide a variable, but we can divide a constant number if the question says that it is not 0. So if, okay, the situation that we're facing is b equals to b square root x 9 minus x squared. And earlier on in the question, they say that b is not equals to 0. Then you can definitely cancel it out. Because it's not equals to 0 for sure already. Okay? But just to make it a habit, a good habit is that don't care what is the condition, shift it over, factorize. Okay, then we can see that x is equals to 0 or 1 minus square root 9 minus x squared equals to 0. Okay? Then when you do this, you will see all the available values, and if the question actually says that x cannot be equals to 0, then you could just reject it. Okay, so that would be a better foolproof way. If you like to, you could simplify this to 2 square root 2. That's fine as well. Nothing wrong with that. Okay. Once you get your dy over dx, substitute in these 3 numbers, okay, individually into the dy over dx, and you will find that the gradient will be 3 at 0, 0, and negative 7 at square root 8 and root 8 and also this point. How I knew that the y coordinate would be this when I only found the x is because my equation here is y equals to x. So my curve and my line, okay, they intersect. So that point must lie on the line y equals to x as well. So it was an easy identification for the y coordinate. Okay. Of course, you could also do as per your routine that you substitute in to find out what is the y coordinate. In this question, they did not specify to us for the points, the coordinate of the points, but because there are so many points that we're looking at, it will be good to have the coordinate or at least mention what is the x value, okay, to give you that gradient value. Okay. Next, question 11. May I know what is the issue for question 11? Answer? You don't know how to do? Okay. So, when you don't understand the question, we are given the curve at which the tangent is parallel to the line 5x minus y equals to 0. I am making a guess that there is no habit, okay, for you to actually draw the diagram and illustrate it. When you lack that habit of drawing it out, okay, you will find that it is very difficult to start and know where you want to, or know what you want to find, okay, in order to solve the question. So, in question 11, we are given a curve. Really, you can just draw anything, any curve. And we want to find the coordinates of the point at which the tangent is parallel to the line 5x minus y equals to 0. So, let's say this is the line 5x minus y equals to 0. Okay, and I want to find tangent that are parallel to this. So, parallel means that I need to have one line that's like that. Okay, so I want to find out what is this point such that I can have a tangent parallel to 5x minus y equals to 0. Okay. So upon looking at this diagram, Answer, could you tell me what will you start off doing first? What does parallel means? Same gradient, right? How am I going to determine the gradient of this straight line, 5x minus y equals to 0? If given a straight line equation, how do I get the gradient? Shift the 5x and then gradient is no what? Negative, positive, right? Yeah, okay. Gradient is 5, right? So we know that the gradient of the straight line is 5. The gradient of this line here is going to be 5 because they are parallel. What can I do with this information? Zhen Quan, what do I do with this information? Gradient equals to 5. Gradient of the tangent. You know the gradient of this, you can find the gradient of the tangent. I need to find the coordinates of this point. What can I do with this information that gradient is equals to 5? Is there anything that I need to do first? dy over dx, right, of which one? The curve. Okay, so we differentiate the curve in order to get, okay, so this is a product of two factors, you're getting quadratic. I find it easier to expand and then do my differentiation, okay, minus 6x minus x plus 2. Up to you, you may want to just do product rule. Okay, so we find that the derivative is actually dy over dx, which is 6x minus 7. Okay, so the derivative tells you the gradient of the tangent. Gradient is 5, so 6x minus 7 equals to 5. And we find that x is equals to 2 over here, and we need to find out the coordinates. So at x equals to 2, y is equals to, substitute into which one? X equals to 2. Substitute into 5x minus y or the curve. Yeah? The curve, right? Because this is the point of the curve, not on this line. So y equals to 3 times 2 minus 1, 3 minus 2, you will get 0. So tangent is parallel to y equals to 5x at 2, 0. 2 minus 4. Sorry. Okay, any questions? Alright, otherwise, could you please submit your homework to the front? All in. You got question there wrong. Okay. All in. All in, right? Okay, let's continue to look at equations of tangents and normals. Could I just check that, did I complete try 1? No, I finished part 2. I haven't do part 3, right? Okay, so just a quick recap. In the last lesson, we recall what is a tangent and what's a normal. Tangents and normals are actually perpendicular to one another. Okay, so we can find out the gradient of the curve itself. Then with the point, we can find the gradient of the tangent. Okay, and with this point, which is a normal, I can find the gradient of the tangent at this point. Then consider the negative reciprocal, so negative 1 over that gradient, to determine the gradient of the normal here. Okay? So in part 3 of try 1, I want to find the equation of the normal at where the curve intersects the y-axis. So there's no clear coordinate given to us, but we can deduce the coordinate. Since it is intersecting the y-axis, that means what is equals to 0? X equals to 0, yeah? Okay, so y equals to x cubed plus 6x minus 15. Okay, curve, we let x equals to 0. So y is negative 15. Okay. But actually, we don't need the y value, right? Because after all, we find dy over dx. Okay, we want the x value. Sorry, extra steps here. Okay, so our dy over dx will be 3x squared plus 6. Okay. We can find out the gradient. And more importantly, more specifically, it is the gradient of tangent that we're finding. That will be equals to 6. Then what do we do next? What will we have to do next? Joseph, what do you think? To answer the question. Yes. You want to find the equation of the normal at where, yeah? Minus 5. Yeah, I have minus 15. Did I write wrongly on my book? Oh, I made a different notation. Okay, minus 5. But doesn't affect anything. Sorry? What's a normal? I just said it 5 minutes ago. What's a normal? Can someone else answer this question? What is a normal? Yes, so what is a normal? Oh, Mrs. Holmes. Yes, a normal is
The line perpendicular to the tangent.
Change the gradient.
which? So
Do minus 1 over 6.
negative 1 over 6. Okay, so gradient of normal equals to negative 1 over 6. Then, how to find the equation? So, equation is of a straight line. Normal is a straight line.
Y minus something.
Y minus what?
Y minus 5. Negative 5.
Y minus negative 5.
Equals to 1 minus negative 1 over 6. Get x minus 0.
Yes. Let's see. Okay. So actually we still need the y coordinate. But it was easy to identify the y coordinate because after all it will just be this, because intersecting the y-axis, which is the y-intercept. So from any curve polynomial that you're given, as long as x is equals to 0, then the constant number will be the y coordinate. Okay, next, try 2. In try 2, we have that the tangent to a particular curve has the equation y equals to ax plus b cubed, a not equals to 0, b equals not equals to 0 as well. And that tangent at the point q is perpendicular to 6y equals to 6 minus x. Okay, could you all draw a diagram to illustrate what this question is saying? Okay. Just give you 30 seconds, illustrate what the question is saying. We illustrate. Okay, I see a lot of hesitation. There's no need for an accurate diagram. We are given a curve, draw a curve. Okay, maybe I always like to draw a quadratic shape. It really doesn't matter. Okay, so a curve, although it's cubic, like I mentioned, doesn't matter. We got a point Q08, anywhere will do. Okay, tangent to the curve at Q08, tangent. So curve, this one, tangent, this one. Okay, and then this tangent is perpendicular to 6y equals to 6 minus x. Okay, they did not say that 6y equals to 6 minus x lies on the point Q itself. Okay, so 6y equals to 6 minus x could be a line anywhere that is perpendicular to the tangent. It is not helpful, okay, if you decide to put this line on at where the Q is. Okay, because it will actually cause you to think that 6y equals to 6 minus x is the normal, where it isn't. Okay. Right. So let's start on working this question. So we want to find the value of A and of B. Let's try to extract as much information as we can from the given info. So we got Q08, we got the curve. Curve, we have A and B's that we need to find. So let's just keep it at that first. Maybe let us make use of this straight line 6y equals to 6 minus x. With 6y equals to 6 minus x, what would be a necessary information that I will try to take out of that. What do I want to take out? Gradient, right? Okay, we take a gradient out of this first. So 6y equals to 6 minus x. Y will be equals to 6 over 6 minus 1 over 6x. Okay, so must make it into y equals mx plus c form. And the gradient equals to negative 1 over 6. And what will the gradient of the tangent be equals to? Wait, what's the gradient of the tangent? 6. Okay. So having the gradient of the tangent, gradient we think of the derivative. So let's do the derivative for y equals to ax plus b cubed. Now what is the derivative? Answer? Square. That's it. Okay. So power our chain rule. 3 bring down, inside differentiate. So we get this, yeah? So 3a ax plus b bracket square. Okay. So since we know the gradient of the tangent, we now am able to get this equation. Okay. Yeah, right. Okay, so but with this equation it is not helpful because we got 2 unknowns. Whenever 2 unknowns, we need 2 equations to solve. How do I get another equation out? Wait, now what do you think? Is there any information that we have not yet used? Find the tangent. Find what of the tangent? Equation of the tangent. You want to find the equation of the tangent. Then what do you want to do with it? Simultaneous. But you still got your A and B unknown one. I tell you, if you, okay, right now is saying, we get the gradient of the tangent, which is 6, and we got this point. If we were to go and figure out the equation of this line and try to solve simultaneous with this, okay, it is not helpful because at the end, right, you do simultaneous, you're trying to find a point of intersection. You already got a point of intersection. And most likely you will end up having the same, you will get this thing. I'm quite sure you will get back this equation. Okay? So sub in what x value? 0, 8. Sub in q, the point, is it? Into this one. Sub into the equation of the curve. Okay? So, hang on. Did I make a mistake here? I forgot one thing. Gradient of tangent. Sorry, I forgot about the 0 here. Because it is at q. Okay, because at q08, then you will have this one, and we need to sub in the x, right? So 3a. Oh, what's this? 3a plus b times b squared is equals to 6. So ab squared is equals to 2. And as what Amberly was saying, this point lies on the curve itself. So y is 8 equals to a times 0 plus b cubed. Okay, and I will be able to see that b cubed is 8. So b is 2 or negative 2. Am I right? Right or wrong? B is 2 or negative 2? Jared, what do you think? B cubed equals to 8. So B is 2 or negative 2? 2 only, Okay? Because taking cube root, not square root. Okay? So b equals to 2, so a times 2 squared equals to 2. So 4a is 2, a is half. So we find the values of a and b. Okay? And only in fact in part 2, then we are trying to find the tangent and cube. So actually, based on the structure of the question, it will suggest that it is not necessary to find the equation of tangent and cube first before finding the value of a and b. Okay, so to find the equation of tangent and cube, we got the gradient, which is 6, and the point 8. So the equation of the tangent would be y equals to 6x plus 8. Okay, questions? Otherwise, let's look at another question. Looking at the time, I'd like us to see exercise 13.1, question 12. Okay, so let's look at this. We have the curve y equals to x cubed plus 5 diagram given to you. Part I, we want to find equation of tangent to the curve at x equals to 1. Okay, so Ling Hui, what will you do to start off this question? Differentiate? Differentiate what? This equation. Okay, so what do I get if I were to differentiate this? Sorry? 3x squared. Okay, then what next? Nicole? What next? I'm sorry? Find the point of intersection between what and what? The tangent and the curve. How am I going to do that? Sub x equals to 1 into the equation, okay. Then the point now is 1, 6. Then what's the next step? How do I find the gradient of the tangent? X equals to 1. Sub into the dy over dx. So at 1, 6, dy over dx is equals to 3, 1 square. So gradient of tangent equals to 3. And let's complete this question. Equation of the tangent, what would it be, Amanda?
Y minus 6
Okay, 1 minus 6 equals to 3 bracket x minus 1. So y equals to 3x minus 3 plus 6. And the equation will be y equals to 3x plus 3. Okay? Part 2, we want to find the coordinates of the point where the tangent meets the curve again. How to solve? Siying, what do you think? How do I find the coordinates of the point where the tangent meets the curve again? What does it mean when the tangent meets the curve again? What do I mean by the tangent meeting the curve again? What does meeting means? Joseph say intersect. Would you agree? Agree? Why not? That it is saying that this is the tangent. Why aren't we saying that I'm trying to find another point that shares the same gradient? So I'm asking two options now. You're looking at intersection or tangent or another tangent having same gradient. What is correct? Intersection or having another tangent having same gradient? Nadia, you think? Intersection? Okay, so we are talking about meeting, so the tangent meeting the curve, so we are actually talking about intersection and not about another point that shares the same gradient, so they actually mean different things, yeah? Okay, so since we want to find intersection, then what must we do? Ying, what must we do? This is the point where it is 1, 6 already, right? We are trying to find this point though. How must we do? Could anybody help? Wait. Wait now. How to find the intersection? Joseph? Simultaneous, right? Am I talking to myself or am I getting through to anything? We are given the equation of the tangent. We found it in part I already. We want to find the coordinates of the point where the tangent meets the curve, meaning intersect the curve again. So one line, one curve intersect simultaneous. That should click already, okay? So equate them, solve simultaneous. X cubed minus 3x plus 5 minus 3. And we get x cubed minus 3x plus 2. Now how to solve this? Irvin, how to solve? Huh? You can say what? Okay, so because you know that 1, 6 is already, okay, one of the point where there is an intersection, okay, you can say that, okay, when x is equals to 1, you could submit inside, surely it will be equals to 0, okay. Otherwise, you just go through your usual routine in solving a cubic equation because it's power 3. So 1 cubed minus 3, 1 plus 2 equals to 0. X minus 1 is a factor. So we will do long division then. And we can factorize to see that x minus 1 times x squared plus x minus 2 is equals to 0. So x minus 1 equals to 0, or x squared plus x minus 2 equals to 0. This one we can factorize. So we see that x equals to negative 2 or x equals to 1. X equals to 1 is not what we want, okay, because that is already the given intersection point. We just want to find when x equals to negative 2. Substitute into either the curve or the line, it doesn't matter, since that point or line is an intersection point. So y equals to 9. Therefore, the point is at negative 2 and, hang on, sorry, it's calculated, negative 2 and negative 3. Questions? Okay. Otherwise, I'd like you to do for homework for this topic. I don't know what your BS is supposed to imply. I'd like you to do question 4. So exercise 13.1, question 4, 6, 10, 10, 11, and 13. Okay, due by next Monday then. That would be when 8. Okay? Also, 8 is here. Okay? I'll just end here today. By the way, I just want to also talk about my initial intention to see you all during your POA but non-A maths periods. Okay, I realize that my time is rather packed. Okay, so in the sense that I have many other things that need to do, etc. Okay, so I'm not able to actually schedule and come up with something. Okay, so what I would suggest is that if you need me to see you for consultation, you can still book me for consultation on your own basis. Okay, at least 3 days beforehand so that I can work out my time. Okay, so I can see you for consultation. I understand that some of you have to do self-study and then have to do compulsory consultation. You may want to consider making use of that time. Then you don't have to stay back after school.